This is your phase and path difference. We started this last class. আজকে এটার উপরে build up করব. So we'll be starting a topic today called stationary waves. Okay, so stationary waves হচ্ছে the most important part of waves, and ওটার পরে আরেকটা topic আসবে, that's diffraction. So that will be the end of waves. So let's look at the concept of phase difference. Okay. Right, so as you can see here, you have two waves, a blue color wave, and there's this red color wave out there. And these two waves have everything identical. So when we mean everything identical, it means it has same frequency, wavelength, and velocity, okay? So the two waves are absolutely same in every manner, right? But there's something different about them, clearly. And the thing that's different about them is that there's a gap between them. And this gap is important when waves interact with each other. So to give you an idea, let's say these are two waves or wave particles, right? And what do wave particles do when energy passes through them? They oscillate, right? And if it's a transverse wave, which way would they go? Up and down, right? So this up and down in their fixed position, and wave where energy. So imagine this is a particle, right? And it's going up and down and doing like a cycle, right? And there's another particle there that's doing the same thing, right? They're going together. But what if they're the same wave, same everything, right? But this one and this one are not doing the same thing. As in, if this goes up, that goes down. If that goes up, this goes down. But they're doing everything in the same manner. Mane hocche, or their frequency same, or their wavelength same, or their speed same, or their amplitude same. Everything same about them, right? So, but are they actually same? If you look at what they're doing, are they entirely same? No, right? If this goes up, doesn't that go down? And that accounts for something at least, right? And this behavior difference is what we refer as either phase difference or path difference. So, what's a phase? So to understand phase, you need to understand the concept of a unit circle. A unit circle is basically the idea that the sine function is the vertical height of this line that goes in a circle. On a circle, je line ta jacche, a line ter vertical je height that is your sine function, and cosine function is which one? The horizontal length. Okay. So do you see if you go here, the angle is 30 degrees, and vertically at the height that's the red line is actually half. Sine 30 is how much? Half. Like, you know, calculator, if you play sine 30, right? How much is it? Half, right? So similarly, if I go to 60 degree, 70 degree, whatever the sine value is in your calculator is basically the height of that thing. So therefore, when you reach here, what is the sine function? Sine 90. And how much is sine 90? 1, right? So as you keep going around, so you know, if you go to, let's say 135, 150, 180. At 180, what is the value? 0, right? And that's the value for sine 180, right? Sine 180 is what as well? 0. Now, as you keep going down, values will hover back for it. But this time, what kind of values do you get? Negative, right? And then eventually you come back here. So to me, the short values will near plot koro, all the vertical values. If you take them and you plot them into a graph, what graph would you get? A sine graph. That's the origin of sine function. Tomar trigonometry graph plot kore na sine graph, like, you know, sine theta. So sine theta kintu ekhan theke ashe. Why am I teaching this? Because when it comes to phase differences, this is one of the best ways to learn phase differences. I'll explain why. So imagine you have a wave that starts here, a blue wave, and this blue wave has now covered how much of a angle? 30 degree. So if I had drawn this wave, a wave ta dekhte kirokom hobe? Just 30 degree cover korche. And then if I go further here, 45 degree, the wave would go a little higher, right? So if I keep going like that, the wave would go a little higher, right? Different angle. And the highest value would be achieved when your angle is how much? 90. So 90 degree, the graph would peak. That's 90 degree there, right? But then after that, what does the value start to do? Go down. So you'll find the value start course. And when it reaches that point, what is the value? 0, right? And when would that happen? When the value is how much? 180, right? In the graph plot. Now imagine this is moving up like that and goes to 30, which means where is my blue wave right now? 30 degrees somewhere here, right? So this new wave starts to form. And this new wave is exactly the same as the blue wave. Same wavelength, same frequency, same. So wouldn't they always follow the same gap? You know, it's faster. faster we give a gap plus slower we give a gap plus but if they're at the same speed, right, what will the gap remain constant, right? And that is what results in a scenario that looks like this, where the two waves will move in around circles, but what will be there always in the two waves? An angle, right? And this angle is what we refer as a phase difference. Okay. So we take a diagram together like this. So if you look at the blue wave here and the red wave here, isn't there a gap between them? That gap that you see here, that gap there at the start, right? That gap that you see there is referred as the one between the two phase difference. Now, unfortunately, a phase difference has to be always represented as an angle and as a radian. You guys know how to convert from degree to radian. So if you don't know, if you want to convert from degree to radian, the conversion is radian value is how much? Theta by 180 into pi. Done on it? Have you heard of this? Or how do you guys convert? You guys seem a little apprehensive. Like this. Same much as you guys. Okay. So yeah, that's how you give it. So your answer will always be in radians. Okay. You can't give it in degree. Do they accept degree in your exam? Sometimes they do, right? But always they will accept what rather the radian mode. Okay. And yeah, that is what the conversion is. So তোমরা যখন একটা wave represent করবে এখন থেকে, a wave will be represented in form of what all the time? Angles. Okay. So can you then tell me, if I have a wave, what are the parts on this wave in terms of angle? চারটা জানতে হবে. So the first one is 0. The peak value that you have here is going to be how much? This peak, the first peak value কখন আসে? 5/2, correct? How much would that be? Pi, right? How much would that be? 3 pi by 2. And how much should the last be? 2 pi. So whenever you want to compare a wave now from future onwards, right? What would you use to refer to the wave? Angle. Acha. So I'm an easy example day. There's a point on this wave that I'm concerned about. When I need to look at that point. Typically, if I told you this is the point, right? How would you locate this point? Without angle. The pointer is a particle, right? I want you to locate this. Diagram na draw kore, tell me where that point is. What would you say? There is a way. What is it? What I'm asking is very simple. Tell me a phrase or a sentence, right, that will tell me where this point is without drawing a diagram. Ar ami tomar ota use kore, your phrase use kore, I can actually find the point. Ki hobe? Na angle use korte parbo na. Kachi. Okay, so the thing is that we normally had used previously something known as amplitude or displacement. Eta displacement na? So if I told you that this particle's displacement is 5 centimeters, right? That's 5 centimeters. And the amplitude is the maximum displacement, and that happens to be how much? 8 centimeters. Wouldn't you able to figure out where that is? But it comes with a flaw though, key flaw. 5 centimeter kintu ekhane duibar cross kore. You see, there's a 5 centimeter there as well. So do I exactly precisely get my position? No, right? So etake overcome করার জন্য, what did we decide? To break down the whole wave into angles. And if I now want to point that out, I'll say, let's say 135 degrees. And 135 degrees is that radian je value ta ashe, and you know precisely what I'm talking about. বুঝছো জিনিসটা? Now amplitude er arekta flaw আছে. Let's say I just tell you 6 centimeters. Okay, the displacement. Can you tell me where is it on any wave? A wave, random active wave, 6 centimeters in my particle lies, right? Can you tell me where that location is? Impossible, because if it's a wave that is 20 centimeter amplitude, 6 centimeter kintu onek niche. If the wave is an amplitude of 6 centimeter, what am I talking about? The topmost point. So when you just say raw data, right? 6 centimeters, it doesn't really tell us what we're looking for. So once again, to wrap this up, we have to use what to demonstrate and study our waves, angles. Okay, is that okay? Acha. So angle today is very reliable. Wouldn't I be able to use angle to find these differences, right? So these kind of differences are referred as phase difference. So what's the definition of phase difference? Phase difference is the difference in two waves in terms of what? Angle. Okay, so phase difference, difference in the oscillation, difference in the oscillation between two waves. In terms of angle or phases মানে হচ্ছে ওই পাই সব সব stationary waves is their first page, so page 44. Another example of phase difference. We'll see plenty of scenarios like this. This is just the introduction. I'll show you multiple types of phase differences out there. Just a moment, I'll give you some examples. Are you guys done with the previous one that I showed? We'll practice some questions now based on the phase differences. Okay, mainly you need to just know the definition and diagram থেকে একটা এখানে phase difference কত ছিল দেখি নাই. Can you tell me what could this be? 30-degree ছিল. When I was basically showing this example here on the right. এখানে অ্যাঙ্গেলটা 30-degree ছিল. So can you tell me what is 30-degree in terms of pi? They're like radian. 30-degree in radians. Yeah, it's pi by 6. Okay, let's practice some. You'll get better at this. A duta question আমরা try করি. Okay, so these are two questions showing two different waves. Operator mode, there's a red and a blue wave. Niche, the green and the purple wave. Find the phase difference between the two waves. Okay, so they're exactly identical waves out there. You need to find the phase difference between the two waves that you see. So দুইটার মধ্যে try করো. আমি hint না, মানে I'll tell you what the value is here. এটার এই জায়গায় cross করে, আচ্ছা? So that's the place. মানে maybe the diagram might be not clear, and that crosses at that place. Okay, so what are the phase difference between the two waves? Try করো. Pi by 2. Pi by 2. Acha, okay. That's the more common answer, but unfortunately, that's not the answer. Okay, I'll explain why. আর কোনো answer তে কোনো বলতে পারো? Pi by 2 তে একটা problem আছে. Right. So our syllabus, it actually syllabus problem, the problem. The syllabus sector requirement. So whenever you want to find phase difference, right, you need to compare two particles that are doing the same thing. Maneboli. So there's a wave given to you. It's a very random wave, and there's another very random wave out there. This random wave must connect a gap enough. Now, what you need to do is you need to find the particle doing something, and then you find on the other wave that particle doing the same thing, and then you find the gap. Okay. So ekhane the red wave they start kori. Red wave er moddhe 3 pi by 4. 3 pi by. That should be the answer. Chamboli, look at this. A red wave er moddhe the particle starts from where? 0. And which way is the particle oscillating and moving? Upwards. Do you agree? Okay, so the red wave. On the blue wave, find something that's exactly identical. So where is that? Is it this point? Now, you pointed to the particle is going which way? Downwards, right? Is it this point? It's at 0, and which way is the particle moving hereafter? Upwards. So it should be that, right? So what you need to do is you need to compare between these 2 points, and that's a convention. Okay, mane tomader syllabus whenever they give you MCQ options, you'll find this is the one they look for, right? So what is the gap going to be here between the two? It's going to be this part here, right? So how much is that? 3 pi by 2, right? So etar phase difference হচ্ছে 3 pi by 2. এটা হচ্ছে convention মানে that's what they normally do. Okay, so it might not seem logical, but other requirement হচ্ছে to keep some consistency, that's what you do. Okay, so 3 pi by 2. এখন art issue আছে এখানে. Can you tell me which wave started first, the red wave or the blue wave? Which wave started first? প্রথমে কোন ওয়েভটা আসছে? How do you know that? The blue one. Right. Both started at the same time. Our question is which wave came first? So the common misconception out there, which most of you said online or both the same thing, is that it's the blue wave. And your assumption is that the blue wave came from like here. Oi part jeto amar picture nai, it came earlier, right? But it is very possible that the blue wave just started from the top. What's wrong in that? Karan, if you think of an oscillation, right, like a pendulum, do the imagine koro, and this is 0, right? And I want the pendulum to oscillate, mane move kora. What do I need to do for it to oscillate? Just if it cherry dao like, do I need to do something? Yeah, I need to take it somewhere, right? Which way? Left or right? Somebody editing age, am I not taking it to its maximum height? And then if I release it, will it be a sine graph or a cosine graph? Sine graph start kore kotha theke? 0 theke. Cosine graph starts from where? Maximum, right? So the pendulum to just somehow started oscillating from center, it would have been a what graph? Sine. But our pendulum to ki ekta side niye jete na maximum the charle tapor it oscillates, right? So where does it start from? Maximum. So the idea that you feel that the blue graph doesn't start here and starts earlier is actually incorrect. Okay, it can start from here as well. In fact, the red starting from 0 is more unlikely, because for waves to be generated, what do you need to provide them? Energy, right? So don't you need to take them somewhere before they start producing energy, right? So yeah, the idea is that ওই type of confusion will avoid করার জন্য what they tell you to do is just take two similar points on both the wave and compare those. Okay, don't try to compare this and that, which are gets complicated. Okay, so yeah, just look at the similar points and you compare and you find your answer, right? Acha, so that's one of the things that we need to look into. এটা বলতে পারো কি হবে answer তাহলে? Sorry, both start at the same time. One at the origin, one from its maximum displacement. এটা কি হবে? Oh, sorry, this is time. It's actually the same question. I just flipped it over. So, কেমনে করবা দেখো, এখানে look at the green wave. Green wave টা উপরে যাচ্ছে এই জায়গাটায়. We always consider this point, okay? And purple টা উপরে যাচ্ছে কোন জায়গায়? এই জায়গায়, right? And you find the difference between these two. So, what is the difference between these two? No, just pi by 2. Okay. Now the confusion is, eta 3 pi by 2, our pi by 2, you take them possible. It's something you learn in math, which is that your angle of 3 pi by 2 and pi by 2, right, are actually the same. If you look into the values of maxima, right? So 3 pi by 2 is a lower maxima, pi by 2 key, higher maxima, right? So exam যখন এই type of question আসে, they'll accept both of them, but luckily MCQ they'll only give one of the option. So এই question option গুলো কি হতে পারতো? Pi by 2 হতে পারতো or 3 pi by 2, দুইটা একসাথে কোনোদিন দিবে না, because both of them could be possible. So ওরা মাঝে মাঝে MCQ তে the obvious answer না দিয়ে একটা multiple দেয়, and that's possible. If you did trigonometry in math, like 30-degree জায়গায়, you can also write what? 150 for a sine function. Or you can write 360, 390, right? Do you understand what I'm trying to say? You can add like 180 and 360 and 180, you still get the same values. So yeah, these are all applicable here, okay? Right, so essentially phase difference final idea concept ki etu bole nei tomaderke. You need to find two similar points and see how do they compare, okay? And at the end of the day, why are we learning this? Our main purpose is for a topic we're going to start today, hopefully. It's called stationary wave. ওইখানে behavior বুঝার জন্য we need to understand phase differences. And luckily for you guys, you don't need to deal with random phase differences. You only have two phase differences that you need to deal with, 180 and 360. So when phase difference is 180 কি হয় and when phase difference is 360 কি হয়, এটা তোমাদের জানতে হবে, okay? So that's the main aim. ওইটা হয়ে গেলে we can start our topic. So before we move on to that, there's another version of this. ওইটা একটু করতে হবে, এটার পাশের পেজে হেডিং দিও. It's called path difference. So phase difference and path difference কে একটু বুঝাই তোমাদেরকে. So we are done with phase. Now we are starting something called the path difference. This, I think you guys will have an easier time understanding. Students who struggle with phase difference, surprisingly, they have path difference খুব ভালো পারে. And then there's a way you can convert them. So you can just learn path differences if you want. Right, so there you go. You have these two waves, and the x-axis this time is distance traveled, and the y-axis is displacement. What's your difference, sir? So the previous graphs that I've given you were a function of what? Time, right? This is a function of what? Distance, right? How far they have traveled. A very simple question for you guys. Can you tell me which wave started first? Which wave started first? Red or blue? Sure. Which wave started first? Why blue? Yes. This is distance, not time, right? If you look at the distance, isn't the blue wave ahead? If you think of this as a road, right, and there are two cars here, like a red car, a blue car, right? Which car is ahead? The blue. The blue has traveled further than the red by this time, right? So you can't use that. But if you go to the time graph, in this case, you can say which wave is first very easily. Which wave is first? Red, because red was there at what time? 0. Blue wasn't there at 0. Blue came a few seconds later, right? So one very important difference between phase and time versus distance graph. Distance graph হচ্ছে literal, মানে তোমার গ্রাফের মধ্যে যে আগে সে আগে, আর time গ্রাফের মধ্যে you have to look for who started at 0. That's the first graph, right? So এখানে if it was a race, right, let's say এটাকে বাদ দিয়ে দিই. If this was a race, who's winning the race? Blue, right? And who will win the race if they both are the same thing? The one who started earlier. When দুইটা গাড়ি যদি হচ্ছে same speed travel করে, right? Who will win the race? Obviously, if they started at the same time, will anyone win the race? No, right? Or দুজন একসাথে যাবে না? So if blue has to win the race, doesn't it need to start earlier? And isn't blue ahead, right? So yeah, coming back to my point, আমরা এখানে যেটা দেখতে হবে is what's the difference in these two waves in terms of length. So can you tell me if I want to explain someone that the blue wave is ahead of the other wave, right? And the wavelength here is 20 centimeters, okay? Wavelength of 20 centimeters. And this is like 90 degree. Can you tell me how much ahead is the blue wave of the red wave in terms of centimeters? Unitary method, I'm believe my whole wave is 20 centimeters. Do you see that data in the 90 degree start hocche? So how far is my blue wave than the red wave in terms of centimeters? Very good. Count quarter ahead, right? Quarter money 20 divided by 4, 5 centimeters ahead. Now I tell this information to someone. Acha tar kono idea nei wave ta dekhte kirokom, tar kono idea nei wavelength ki, and I tell them that I have two waves and one wave is 5 centimeters ahead of the other, right? Is it possible for that person to picture what part of the wave is ahead? Just 5 centimeters there? No, impossible. Why? Because if my wave is 20 centimeter, 5 centimeter key represent quarter. But if my wave is 100 centimeter, then 5 centimeter key represent just like 5% of it, right? If my wave is 5 centimeters, then 5 centimeter key represent the entire wave. So just saying the centimeter value, right? Just like the previous place, just saying the amplitude value doesn't really help us. So we need to represent this answer as a universal value, right? And you almost got the answer. You said this was how much of the original wave ahead? Quarter, right? So if the whole distance is lambda, how much would this gap be here? Lambda by 4, right? So amar jodi purata lambda hoy, right? Halfway কত হবে? Lambda by 2. ওইটার half কত হবে? Lambda by 4. আর lambda by 2 আর lambda এর মাঝখানে যেটা ওটা কত হবে? 3 lambda by 4, a quarter, right? So the idea is that now we'll divide our wave into what values? Lambda values, where this is lambda by 4, this is lambda by 2, half a wavelength. This is how much? 3 lambda by 4. And how much is the last one? Lambda. And this idea of representing your wave in terms of wave is known as path difference. And in the idea of representing your waves in terms of angle is known as what? Phase difference. Does it change my wave or does it change the representation? You know, phase difference, path difference, convert to value, right? Wave change, am I just changing the unit? Just the unit, right? It doesn't really affect the wave. It's like, you know, when you're answering kg per meter cube for density versus gram per second cube, does that change? No, right? What does that change? Right? So similarly, in some places, phase difference is very, very good and used, right? But if you look at it, it doesn't work. So path difference, phase difference, just their representation phase is the one. Angle and path from what distance from wavelength. That's the difference. Okay. So I want to convert right? Which is how we convert phase into path. It's a normal and actually I'm just converting a unitary method for you guys so that you feel a little confident with it. Okay. So phase difference equals to path difference into 2 pi by lambda. If you use this formula, you can convert any phase difference into path difference যখন তোমার দরকার হয় okay y-axis is displacement, x-axis is distance travel. Okay, let me explain a couple of you asked for this online. When to use face and when to use path. Okay, I'll straight go to what our syllabus has. So to relate to easier. On the left hand side, you have these two balls floating on water, right? The red color ball. And do you know what a trough and a crest is? Crest is the top of the wave, trough is the lower of the wave, right? Like the bottom of the wave, of a transverse wave. So there's a ball on a crest and there's a ball on a trough. When the ball on the crest goes down, right, the ball on the trough goes which way? Up, right? Do they move forward, the ball? No, right? Because this is a what wave? Transverse wave. In a transverse wave, the particles can only go where? Up and down. If I want to compare their behavior, right? I have to use cycles, angles, right? So if one goes up, the other goes down, and aren't they doing opposite to each other? Can you predict what's their phase difference? Think angle over তোমরা পাইতে দেখি অনেক mistake করো 180 কেন because আমার যদি দুইটা 0 হয় what would they be doing same if the angle is 360 what would they be doing same if the angle is 180 what would they be doing opposite right so the difference between these two right is 180 or pi right এখানে আমরা phase use করতে হবে I can't use paths here why can't I use paths here because are the particles actually literally going somewhere is there a distance traveled by them to a no right কোনো distance নাই তো they're not reaching to a new location so এখানে phase use করতেই হবে unfortunately right on the right hand side look what's happening so there are two lamps out there আর দুইটা lamp থেকে wave যাচ্ছে and they're hitting a point there and there are multiple waves traveling and both the waves go and meet at a location right তখন aren't the waves actually going somewhere right and if I told you that there are let's say in this particular direction there are 20 waves I mean if I count all the waves here there are 20 waves here okay and this one comes from another direction it has 17 waves when they meet this location what's the difference in the number of waves they have 3 right this is known as what difference path difference how do we draw this It's interesting. We have this in our syllabus, like a diffraction chapter we'll learn. So can you tell me which wave has more than the other? Like which wave has more wavelength than the other? The green one. So এটা যদি আমি draw করি, I'll have like green wave কয়টা extra? 3. So that's like 2 waves. And then we have 3 waves. And then who shows up? The blue. So what's the difference between these 2 waves in terms of lambda? So if I count the number of waves here, how many extra waves are there in green? 3, right? And this 3 lambda is referred as the what difference between the 2 waves? Path difference. Because একটা আরটা থেকে কতটুকু extra travel করে? 3 waves, right? That's why in this scenario, what do I have to use? Path difference, the length, because they travel somewhere, right? But on the left hand side, do the waves actually or the particles go somewhere? No, right? What are they doing? They're in cycles, but their cycles are a little off, right? So it can represent angle it. So our syllabus has both of these things. You might feel like it too difficult to grasp what's going on right now. When I start using these, you'll understand why they exist. Okay, but I have to teach this before I get there. So that's why just keep in mind there's something called a phase difference and there's something called a path difference. Phase differences are used in certain places. Path differences are used in certain places as well. Okay, can you interchange them? Yes, but you don't really get a benefit out of them. So path এর জায়গায় path use করা best হয়, phase এর জায়গায় phase use করা best হয়. Okay, we'll see when that is. Right, so you have these waves here. এখন we will move on to a new thing. But before that, let's see if we can answer this question. এটা তোমার একটা MCQ আসছিল. I don't have the exact question, but this is how it was, okay? 2 particles have a phase difference of pi by 6 on the same wave. The frequency of the wave is 10 hertz. The distance between them is 2.5 centimeters. What is the speed of the wave? So try for it. It's an MCQ, so you know how much working is needed. Forward, it's not that complicated.
So what do I mean by the distance between them?
The distance between them. So remember the 2 balls that I drew? The distance between the 2.
The 2 points.
Yeah.
Even 3 meters per second.
Yeah. Ashit, wait. Do you always consider the wave is 2 pi? Yes, because once it's 2 pi, it creates a complete cycle. So that's one wave. Okay, Koride, it should be done by now. But let me give you like an explanation of what the question is talking about. So you have a wave, and একটা জিনিস একটু মনে রেখো যে phase difference is not really only about waves. It's also about the particles on a wave. It's also about movements of objects. So আমার যদি দুইটা pendulum থাকে এখানে, let me just show you কোথায় একটা আসে. It's not a wave thing. So there are two pendulums here, and I take them to opposite sides and I release them, right? তাহলে কি হবে? ওরা এভাবে যাবে, এভাবে যাবে, right? Are they doing exactly same thing? No, right? They're trying to do similar things, but what do they do each other all the time? So what's their phase difference? 180. Acha, what if it's something like this? They're moving like this and then it goes something like that. So is that 180? No, right? But there's a difference between them. Eta ber korar jonno what do we use? Like pi by 2, 3 pi by 2 something. And what if it's something like this? Okay, carefully দেখো. So একটা start করলো, it goes here, it comes back here, right? So that's one cycle, and then they start doing this. What's the phase difference? 0. How do I show it? Easy actually. I think that was difficult. They both are together, okay? And start below. It went there, right? That's half a cycle. It came back here, and now they're going together. What's the phase difference? Yes, okay. But if you just look at it from nowhere, randomly takale eta dike, what could the answer be? 0 or 360 or 720. So any multiples of 2 pi would be the answer. Around the exam, most of the time, the questions just randomly show something happening. So what would the acceptable answers be in those cases? 0, 2 pi, 4 pi, 6 pi, all even number multiples. So yeah, that's what we can use it for mechanical systems as well. That's what I'm trying to say. So anyways, there's a wave where there are two particles on the wave. Maybe this and that. Just like the example that okay? And what's the phase difference between these two? Pi by 6, right? তার মানে এটা যখন উপরে যায়, এটা maybe নিচে যায় or something. And what is the phase difference between these two? Pi by 6. Do you understand what it means? So একটা ওয়েভের মধ্যে সব পার্টিকেল কি একসাথে উপরে যায়? Not right. Some are going up, some are going down, some are going up, but more than the other, right? So there are a lot of variations out there. So that's the phase difference between these two. But they also mentioned something. The length between these two on a pointer, duta particle মাঝখানে যে length, the gap is how much? The physical length between these two, 2.5 centimeter. So can't I write this statement that pi by 6 phase difference, right, corresponds to how much path difference? 2.5 centimeters. Do you agree? Pi by 6 to gap angle is how much in distance? 2.5, right? Achha, just keep that in mind, hold that thought. We want to find what though of this wave? Speed, right? What's the formula for wave speed? V equals to F lambda. We do know the frequency, and in order to find speed, I only need one more information. What is that? Lambda, wavelength, right? So is there a way I can use this information here to find wavelength? Yes. Pi by 6 to 2.5 hoy, how much angle makes a whole wave? How much angle makes a whole wave? 2 pi, right? So 2 pi gives you how much? And I'm going to use what method to solve this? Unitary method. So x equals to pi by 6 into, 2 pi into 2.5 divided by pi by 6. Okay, to check করবো কত দেয়? 300? 0.3. 0.3 meters. So 30 আসে? আচ্ছা, 30 centimeter. So if I place my value here, 30 centimeter, I get 300 centimeter per second, or how much? 3 meter per second. Clear about this? So what did I use here? I just use unitary method, nothing else. Okay. And there's no need to complicate this. Yes, you can. And once you do that, you'll find that it's actually the same thing. Because I use this to create that formula. And in that case, if you place, what did you place there for phase difference? In that formula, did you use the formula? 5/6, and you got a path difference, right? And then you use that to find the yes. Okay, so I think it's whatever we have done is enough for us to move on. Okay, so I'm going to show you a simulation right now. I'm the phase and path done, by the way. Okay, so phase difference key, difference in angle, path difference key, difference in path. Okay, mane distance. Now let's try to see simulation here. আমরা যে টপিকটা এখন স্টার্ট করব, it's called superposition. Superposition is essentially what happens when two waves meet each other. Okay. Right. It's very interesting what's happens here. So let me explain what's going on here. I'll keep a little low resolution for smoothness. So they cannot. You can see this peak here, and you can see that peak there, right? A type of wave key bola hoy, where it's just one single disturbance. What do we call these? Pulses. Pulses is just one disturbance. It doesn't need to be a complete cycle or anything. Okay. We have two pulses here, and what we're gonna do is we will make them exactly identical to each other like that. Okay. আমরা কি করব একটু দেখো, I'll make the two waves move towards each other, and as the waves move towards each other, right, let's say it's on a string, একটা string এর মধ্যে from the other side a person moves their hand like that, so একটা pulse generate হলো, and I move my hand like this, so একটা pulse generate হলো, and the pulses are moving which way? Towards each other, right? And what will happen is at one point they'll cross and meet each other. We need to understand what happens when they meet each other. And it turns out when they meet each other, they are basically transferring what? These two pulses, energy. So the energies would come, and what would they do? Combine. And the thing is, the energy would give the energy, total energy would be given to the particles. So particles will energy keep over there. They'll create a new movement, right? So let's see what happens here. I'll make it slow so you can see step by step. So as I make the waves move forwards, right? And right, do you see এখানে height বেড়ে গেল at that point? Why? So what happened was this wave has like a small energy given here. This wave also has a small energy given there. Both the energy goes to the same particle. So what does the particle do with the same energy? It adds up. Okay, it's like, you're pushing a ball this way. Somebody else also pushes the ball the same way. Wouldn't the ball gain double the energy? So, it gains energy and rises up. But if I allow it to move further, you'll start to notice that it rises up pretty well. কারণ a orange waveটার value এখানে let's say 4, or a blue waveটার value এখানে 4. So what would the resultant be there? 8. And the energy is in the same direction. And if I allow that to go further, this is what we are concerned about. Do you see that the two waves perfectly mimic each other, right? And ওদের যা amplitude এখানে, right? What would the amplitude of the resultant be? Double, right? But very important, do you think the wave has changed its length? No, right? Did it change its speed? No. Did it change its frequency? No. So only what changed? And this behavior is called superposition. Superposition is when two waves interfere, meet, superpose. The resultant is the vector addition of their displacement. বুঝছো? আর এটার নাম হচ্ছে constructive interference. Okay? It's not over yet. দেখো কি হয়. Do you think this is the end of the wave, or the waves will come back again? Yeah, see what happens? As they cross each other, or they just, go back to their normal ways again. They came here, doubled up, and then they went back like that. So the energy is not being destroyed, right? Now, the one I want you to see is this one. What if I make two waves interfere, but one is like this? What happens? Let's see. So the waves will start to move towards each other, right? And I don't think I'll be able to make this happen, but I'll try. When they exactly cross each other, There you go. Do you see what the black line is? Isn't it flat? So if you were looking at the rope, what would you notice the rope is? Flat. But aren't there vibrations out there? What did they do to each other? Cancel out, right? Does that mean the wave disappeared? Or will they again show up on the other side? Yeah. So if I run them on, you'll notice that ওরা কিন্তু উল্টা দিক থেকে আবার back করে চলে আসছে. And this kind of an interference is known as destructive interference, where they completely cancel each other out. Can you tell me what's the phase difference between these two pulses? মানে একটা উপরে আর একটা completely নিচে. What's their phase difference? 180. আমি বললাম না, you only need to be concerned about two, the 0 and the 180. 0 হলে কি interference হয়? Constructive, perfect. Or 180 হলে কি interference হয়? Destructive, একদম flat. And that's what we'll be building on next class. Okay. When will you be available? Before or after?
Maybe after like 20 or 22nd, like that. Yeah, it's down.
I think maybe you should be close then. Can you give the exam earlier?
I'll be leaving like the day after tomorrow.
Oh. 17, right?
So will the exam be like structure or?
Structure. Okay, once you return, just give me a knock. If Amish is open, I'll take your exam then. Or first week of January.